So if we have to convert between different units, so let's say one simple example, 1 kilograms equals to how many grams? We all know it's gonna be 1000 grams, right? So 1 kilogram equals to 1000 grams. So this term here is called equality terms. So these are our equality terms. And these are by definition. So this is by definitions. So this is by definition. So this is the definition of 1 kilogram, which is 1000 grams. So since these are by definition, so none of these numbers are counted towards the sig fig. So none of these numbers are sig fig. So you just ignore for sig fig calculations. So none of this count as So none of these numbers are counted as sig fig. Sig fig. Remember, when do we calculate sig fig? Sig figs are only calculated when we have a measured value. So let's say you want to measure how much oatmeal you want to put in your recipe, maybe 25 grams, 27 grams, 28 grams. So these are the measured numbers. So we gotta use sig fig in those calculations. So let's say I'm gonna give you a problem here. So questions. Convert 5.2 kilogram into gram. So this is our questions. So convert 5.2 kilogram into gram. So in this questions, the 5.2 kilogram is a measured number. So know this one. So this is, you measured something. Let's say you measured your bag that you are packing for your holiday, and you want to take it on a carry-on on a flight. So you measured that your bag weighs 5.2 kilograms. So this is a measured number. So this is a measured number. So if it is a measured number, it should have a sig fig. So how many sig fig we have? So we have 2 sig fig. Sounds good? So this is a good recap. So now you have to convert 5.2 kilogram into how many grams, right? So how can we do this? So step 1, write down the equality terms. So what is the equality term? So you want to convert kilogram and gram. So what is the equality term? 1 kilogram equals to 1000 gram. So that is our equality terms. Then step 2. So when I ask these questions in test, I give most of the conversion equality terms. So then you have to write conversion factors. But since the take-home exam this time, all of the exams, you have the notes, so you can use your notes to find out all these equality terms. So step 2 would be, come on, erase. Write the conversion factors. All right, so for this particular equation, the conversion factor would be, we're going to have 2 conversion factors. So one would be 1 kilogram equals to 1 kilogram is per 1000 gram, or I could have 1000 gram per 1 kilogram. So you're going to have 2 conversion factor. So let's call this factor as A, and call this conversion factor as B. So you should first try systematically, then once you practice a lot of them, then you can do it very rapidly, right? So practice this way. So you can write 2 conversion factor. Then step 3. So what's given and what's needed? So let's look at the question. So look at the questions. So what's given? We were given 5.2 kilograms. So let's write that down. So given is 5.2 kilogram. And what's needed? So you want to find out how many gram would that be, right? So you want to find out how many gram in that 5.2 kilograms. So we need certain grams. So let's fill in the blank. So we need certain grams. So that's our questions, right? So when you are given like this, so next thing you want to do is given multiply by our conversion factor, and then you're gonna find your needed. That's pretty much all about it. So you have to figure out which conversion factor I'm gonna be using. So I have two conversion factor, A here and B. Which one would be the best fit in this questions? So here is how you should figure out. So here is how you should figure out. So you have to multiply your conversion factor right here. So in your needed, what's on the top? So the gram unit is on top, right? So this is this unit on top, and the kg is cancelled. So you have to use the conversion factor, which will cancel out kg and bring gram on top. So between A and B, which one has gram on top? B, right? So conversion factor B has gram on top. So we're gonna be using that conversion factor, 1000 gram per 1 kilogram. So kilogram on the bottom, kilogram on the top got cancelled, and what left is with Z. So our units is gonna be on G. So if you multiply this number, so what would be our answer? 5.2 multiplied by 1000 is gonna be 5,200 grams. Sounds good? So now you have to pay attention to the sig fig. So which of these are counted as sig fig? 5.2 has 2 sig fig. This is by definitions. So doesn't count. Doesn't count towards calculation. So how many sig fig we should have in our answer? 2, and this matches. We got 2 sig fig. So our answer would be 5,200 grams. So don't forget the units. If you don't write the units, that's -1, right? Good. So follow this strategy. Let me do another one. So let me do another one. Find questions. Let's say how many milliliter is in 3.74 liter. So step 1, equality term. So you gotta find the equality term. So equality term is gonna be 1 liter equals to 1000 milliliter, right? So this is by definition. So this is by definition. So no sig fig counted. Step 2 is conversion factor. So what is the conversion factor? 1 liter equals to 1000 milliliter. So 1 liter per 1000 milliliter, or 1000 milliliter per 1 liter. So I'm just writing this one down. And then step 3, what's given? You are given a 3.74 liter. What's needed? we need certain milliliter, right? So what do we have to do? We have to multiply our conversion factor, right? CF conversion factor. So what is the conversion factor? Are we gonna be using conversion factor A or conversion factor B? Which one were you gonna be using? So we will be using, which one? We want milliliter on top. So which one has milliliter on top? The B has milliliter on top, because the your needed is milliliter. So you want the one that has milliliter on top. So conversion factor would be B, 1000 milliliter per each liter. And then liter got cancelled, and the answer should have 3740 milliliter. So this is 3 sig fig. This does not count because this is by definition. And this one has 3 sig fig. So our answer matches. Good? All right, so let's do another problem, one last problem. So if the conversion factor, if the equality term is within the same unit system, so these are all in the metric or SI unit system, so these are by definition, doesn't count. But if it's in the inter-unit system, if it's between metric and US system, then the definition will gonna count. The one that's measured will be counted. So here is an example. So let's say question 3. What is the distance between Greensboro and Winston-Salem? So let's say the distance is I don't know, 30.6 mile. So convert 30.6 miles into meter. Sounds good? So step 1, write the equality terms, right? So equality term is gonna be, so what is the equality term? So you can find the equality term from the book. So I'm just gonna put the number here. If I would have asked this question in the exam, I would be giving you the equality term. So you don't have to memorize, guys. So equality term would be 1 kilometers is equals to 0.621 miles. So let's keep this problem simple. That way we're not gonna add too many complex things, calculations for now. I'll do that later. So let's do this as kilometer. The point I want to try to make is it will be a little bit easier. So convert 30.6 miles into kilometers. Sounds good. Maybe let's make this 30.62 miles. So pause here for a second and then try to do the math. Then you can come back for your answers. Okay, so this is our equality term. 1 kilometer equals to 0.621. So in this number, this equality term is in between two systems. So this is between metric and US system. So on this number here is gonna be a measured number, because somebody measured exactly how many 1 kilometer would be in terms of miles. So this is the measured number, and this does not count. So the measured number gonna have sig fig, right? So how many sig figs we gonna be getting? We're gonna be getting 3 sig fig here. The zeros on the left doesn't count, so this one has 3 sig fig. All right, so step 2 is conversion factor. So what is the conversion factor in this particular example? So it's gonna be 1 kilometer, 0.62 mile, or 0.621 mile equals to 1 kilometer. Got it? Okay, so that's our conversion factor. And then step 3 is you're gonna follow the protocol given and needed So obviously we're going to be multiplying our conversion factors. Okay, so what's given in our problem? We are given 30.62 miles. 30.62 miles. What's needed? We're going to find out how many kilometer would that be, right? So the answer would be, you have to multiply conversion factor. So which one you want to be using? Will you be using conversion factor A or conversion factor B? Think for a second. You want kilometer on top. So which one has kilometer on top? The conversion factor A has kilometer on top. So you want to have kilometer on top. So 1 kilometer, 0.621 miles. And miles got cancelled. And when we multiply those, so let me use my calculator. So the number that you'll be getting, 30.62 multiplied by 0.621, which is gonna be, my calculator is giving me 19.01502. 01502 kilometers. Sounds good so far? Okay, so now at this point you have to, this is not gonna be the exact correct answer, so you have to write the correct answers. Now you have to look into the sig fig. Okay, so this is our measure number. This is 4 sig fig. And the 1 does not count, so the 1 does not count, but the 0.621 is a measure number, so this one is 3 sig fig. If you have conversion between two different unit system like US and metric, then this is not by definition. So somebody has measured it, so this is gonna be 3 sig fig. So which one? How many sig fig our answer should have? 3 sig fig. So our answer should have 3 sig fig. Good. Which means correct answer would be, you have to drop anything after 0. So if we round that up, it's gonna be 19.0 kilometers. So that should be our answers. Good. Okay, so we'll do some more practice problem with this question conversion factor. So let's move on to the next thing. So here is only aberrations in this interconvert system, interconversion of so what I'm saying, I'm rambling. Inter system conversions like metric to US conversions. The only conversions which is 2.54 centimeter equals to 1 inch. So this is by definition 1 inch. So this is by definitions. So this does not count towards sig fig. So if it is by definitions, then that does not count towards sig fig calculation. So if you have a conversion between centimeter to inch, you're not gonna count this as 3. So you're not gonna be counting this as 3 sig fig. Just ignore all of those. Besides that, everything else you have to count. Let's say you wanna count 1/4 equals to 473 milliliters. So for the conversions, you will be counting 3 sig fig here, and you will be not counting anything on this one side. So this is going to be carried over by 3. So let's move on to the next concept in this. It's a pretty simple concept, guys, which is density. I know you will be in your lab, so I have to finish this. So density is, formula of density we all know, it's gonna be mass by volume. So mass is a measure number, so you have to measure your mass. Volume is also a measure number. Then that means So if it is a measure number, then both of them should have some sig fig, right? So all the numbers should is gonna have sig fig, right? So let's do a problem here. So simple, let's start with the simple. What is the density of what is the density you want to measure? Let's say you want to measure density of a cube. What is the density of a cube whose mass is 2.31 grams and volume is 25 milliliter? Pretty simple. So mass is given and volume is given. So that's pretty simple. So what is the formula? So formula is going to be density equals to mass by volume. If anything is missing from this equation, you can easily find it. I'll give you an example later. So let's say so what is the mass? Mass is 2.31 gram. So what is the volume? 25.2 milliliter. So let's do the math. So 2.31 divided by 25.62. Okay, so my phone is giving me 0.7424. Okay, I'm gonna stop here. It's giving me a larger number. Okay, so it's gonna be grams per, don't forget the units guys, grams per milliliter. All right, so now you have to write down the answer with correct sig fig, right? So the top one, how many sig fig we got? 3 sig fig. Bottom one, how many we got? 4 sig fig. You got 1, 3, 4. Answer should have how many sig fig? You know it. So answer should have 3 sig fig because 3 is the lowest, right? So your answer should have 3 sig fig. So we have to drop anything after 2. So it's going to be 0.2 grams per milliliter. Okay. All right. One more. So do these questions at your own leisure. So so what is the mass? Let's say I'm just gonna give another example. Let's say what is the volume of your phone if the density of your phone is, this is just a random number guys, 20, it's gonna be insane number, and mass is what do you want to say, 25. Okay, so if the mass is 250.2 gram and volume is so if the mass is 250.2 gram and the density is 2.0 gram, then we're gonna have the question is what is the volume of your phones, right? So I'll just give you a hint so you can do the math on it by yourself. So density equals to mass by volume. So what's given? Density is given, mass is given. So what do you want to find out? You want to find out volume. So you have to solve for volume. So I'm just gonna do it my way. So if you know whatever way works for you, this works for you. So you want volume on top, so I want to move volume here to this side and bring density to the other side. Remember when we flip across the equation, everything gets switched. So now volume is on top, density was on top on the left side, so when it goes to the other side, it's gonna be on the bottom. And that's gonna be your formula. So you just follow that formula, right? So what was the mass? 20.1 gram. What was the volume? 250.2. Oh no, sorry. The mass is 250.2 gram and the volume is 20.1 grams per milliliter. So this is 4 sig fig. This is 3 sig fig. So yeah, your answer should have how many sig fig? 3. Then the gram get cancelled, milliliter will go on top. So your answer is volume, so your answer should be some milliliter. And your answer should have 3 sig fig. Okay, I'm not gonna write down the answer for you. You guys can fill this one by yourself. Good? All right. So last thing we're gonna be doing in this chapter is our specific gravity. Have you heard about this term? Specific gravity. I know you will be doing this in your lab later. So what is a specific gravity? It's a pretty simple. You just want to find out how heavy is your sample in comparison to the water. So specific gravity of your sample specific gravity of a sample equals to density of a sample of the sample, because we already defined it. So density of the sample divided by density of the water. You know water, H2O, at 4 degrees Celsius. So at 4 degrees Celsius, density of water is always 1 grams per milliliter. So density of water is always 1 grams per milliliter. So this is by definitions. So this is by definitions. So not counted towards sig fig. So if it's by definition, it's not gonna be counted towards sig fig. So what's gonna be counted towards your sig fig? Obviously specific gravity. So this is a measured quantity because you have to measure your density and measure by measuring your mass, measuring your volume. So this is a measured quantity. So this will be counted towards the sig fig. But the density of water, which we already know, it's 1 grams per milliliter. So this is not going to be counted towards any sort of sig fig calculations. Okay, let's do for our phone. So we know that our phone is 20 grams per milliliter, right? So what is the specific gravity of our phone? So in response to our previous problem, so specific activity of, not activity, what I'm saying? Specific gravity. See, I'm teaching biochem, so I'm still in biochem mood. Specific gravity of our phone based on our previous problem. What was the density? 20.1 grams per milliliter. What is the density of water? Which is going to be 1 grams per milliliter. The bottom one, not counted as sig fig. and the top one has 3 sig fig. So it is going to be, so your answer should have how many sig fig? 3, 20.1. And that's gonna be answer. So look at here, no units. Why? Because the grams per milliliter on the bottom got cancelled by grams per milliliter on top. So specific gravity has no unit. So that's, so that's the answer, 20.1. And that has also 3 sig fig. It's pretty simple. So you want to find out how heavy is your atom. Sorry, how heavy is your any sample in comparison to water. So if it is heavier than water, if it's more dense than water, it will sink in water. So we all know this. If the specific gravity is greater than 1, which means it's heavier than water, or you can call it denser than water, which means it will sink in water. If your specific gravity is less than 1, which means it's lighter than water, which means it will float. So I got a quick question for you. Think. So remember oil, like when you put oil in your water, what happened? Oil floats on water. So oil should have lesser than 1 specific gravity or higher than specific gravity? Higher than water. So is it lighter or heavier than water? So it's obviously lighter than water. So what should be the specific gravity? It's going to be less than 1. So you can find those number pretty easily from this ratio. Okay, so I think I covered most part of the chapter 2. I think one problem, I will do it later, is how to calculate density of an unusual shape. And I think this video is already pretty long, so I'm going to stop here.